Hello, my name is Svend Jepsen. I'm a product expert for small thermostatic expansion valves here in Danfoss headquarters in Denmark. Today I would like to show you a little about setting expansion valves, how it's done, and some things about what not to do. For that purpose I have here 4 valves, and I will show you how the different valves are set. The first valve we have here is the stainless steel TU valve. The setting device is here, and on the end of that we have a top screw. It can be removed using a standard wrench. Once the cap is removed, you can change the setting by using a 4mm hex key. The small TGE valve is also have a top cap you can remove, and it is changed. The setting is changed by using the same hex key as on the TU valve, 4mm. The T2 valve also have the same cap that you can remove with the key, and once that is removed, the setting is changed by using a flat screwdriver. The large TGE valves again have the same cap. It can be removed, and this time the tool to use is a standard 5mm wrench. Just put it on here and turn the setting. When you get the valve from Danfoss and you take it out of the box, all valves that you get have been through a very precise setting procedure, and for that reason you can trust the setting on all the valves. They are precise within ±1 degree static superheat. In this picture you can see how the automated setting procedure works. The bulb and capillary tube is placed in a temperature controlled alcohol bath, and the inlet pressure mimics a typical condensing pressure of the refrigerant for which the valve is designed. The outlet pressure now indicates the static superheat that the valve is set at, and we can now change the setting precisely to the required level. Performing the setting in this way prevents that mechanical tolerances in the valve have any influence on the actual setting of every produced valve. So when you have mounted your expansion valve in the system, you can check the instruction and see what the setting is, and then you will look at your performance on the system, and you can evaluate if the valve needs to have this setting optimized. So doing that, if you take the tool, mount it in the valve, turning clockwise will increase the static superheat setting, and turning it counterclockwise will decrease the superheat setting. So when you have changed, or when you are changing the static superheat setting, please take care and do not change the setting more than half a turn each time. After you have changed the setting, leave the system running until it has stabilized with the new setting, and check your performance again. So when you are satisfied that the setting that you have reached is what you want to have, which will give you the most optimal performance, then it is very important that you return the cap to the valve and tighten it with a wrench. You can look at the instruction to see the torque that we recommend to tighten the cap with.